Okay, thank you very much. I'm bound to this thing here because we are recorded. Normally I'm bouncing around, but that's not possible now. So welcome to this session together with my son Martjin. We've kind of made a full stack development in the digital era. Swift, IBM Cloud, Red Hat OpenShift, IBM Z, built by Millennials. So of course one of them is Martjin, another one is another son and some business partner that we involved in here as well. Probably he drops in later. We're going to use that. So this is about well, the whole full stack development. What I like to see also how to put this into a kind of IBM cloud story. Might have seen this just if you're for your own mind. When did you ever heard the first word about the word cloud? That must be 8 years ago, 9, 10, something like that. And interesting to see is that in what we have called the first chapter, that only about 20% of the workload has been moved actually to the cloud in those last 8 or whatever years. And it was very much about consumer-driven innovation, experimentation on digital and artificial intelligence, user application, public cloud mainly. And IBM thought, well, we need to go to the next step, the next level, and that's what we called Chapter 2 within IBM terms. And we can see that we clearly are moving more enterprise-driven, not so much consumer-driven, etc. What I thought was an interesting chart that I found in the multiple charts that we have is this one. Cloud native and legacy apps will coexist for at least the next 10 plus years. And if you look at this bar, many people from the mainframe think, oh my goodness, the mainframe is going to be that bar on the bottom, and it's getting minimized. Whereas I think, if you just say we are about here today, 20% has been moved. What I like to think is that the platform itself, the mainframe itself, can be a large part of that bar on the right-hand side, and not only the dark blue thingy, but mainly the bluer, the greener part. Hi, Nigel. So, because we are thinking that the mainframe typically is left alone in any cloud discussions we have, whereas I would say, no, that's definitely not the case. If you look at cloud, if you look at cloud native applications, if you look at what we are doing on the platform, it definitely has a large part of that far right-hand bar above the line. So focusing on Z in this part, we see a couple of angles where you can see, okay, where is IBM then with the Z platform in this cloud world? And you can have a couple of angles. We have 4 angles here. We think that we transform the platform to be really a player in the cloud world. We would like to give the cloud native experience like young developer. You may sit down if you would like, but Martjin, don't. You will be way before we start talking about you now. So we want to give the customers the experience that even if you work on a mainframe, give them a cloud native experience. And of course, if you run your private cloud, Z has a part in that, and also on the public cloud. So if I want to dive in it a little bit, I mean, it's more about what we are going to show you later on. But in transform to cloud, we basically say, okay, NSX Connect is one of the things that we also using in this part, that we can REST enable anything that's on the mainframe, whether it's KIX, IMS, or even VSAM files or BSAM file or SMF records for that matter. We can expose them now as a REST API. We have other tools to make sure that whatever you do on the platform, it is available for a cloud environment. If you want all your log data and you send it to Elastic or AppDynamics or Splunk, please do so as it is any other platform. From the cloud native experience, I think a lot of things happening right there. So you probably heard about SOE, the project that makes the whole mainframe interfacing much more like what you used to do in either a desktop environment or putting command lines to it in a JSON format and receive JSON back. We have the open source Jenkins. We do run Git on the platform. We have Docker, Swift, which I will talk to in a minute. and also the frameworks like Spring. So it is really about those two things, and just to be complete in this story, the private cloud, if you want to run IBM Cloud Pack, you can run it on OpenShift on Z. It's being announced, it's not really available yet, but will be shortly. We have other things like ZOS Cloud Broker that makes the interface from a Red Hat OpenShift environment directly into your Z environments. If you want to run a blockchain on-premise, please use an IBM, because we use that blockchain for our public cloud service as well. So that's the angle of going to chapter 2 with all those 4 angles of Z. And we are focusing more about transform for cloud and also the cloud native experience. Still okay with me? Not too much Dunglish here? Okay, so that's my version of English. So enterprise with IBM Z, first thing, transform to cloud. If I do a whiteboard session, we typically see we have our secure enterprise data, and we have our online processing, batch processing, typically written in COBOL, PL1, assembler, that kind of stuff, which don't necessarily have an open interface. It was more a legacy interface. On the other hand, we see it in the public cloud. We have all kind of Dockers and microservices, REST API enabled by nature. So we have to kind of gap that bridge. And one of the products I already mentioned, and we will mentioning throughout this presentation, is to make REST APIs out of your traditional mainframe applications, being, in our case, ZOS Connect. So we have other products, but I don't want to swamp this foil too much. Secondly, if you do for the cloud native experience, what we have there on the platform. So in a traditional enterprise, although you can run your COBOL code within a Visual Code Editor as well, we see that there are a lot of applications and a lot of DevOps things are coming to the platform as well. There were some sessions about Git in this conference, Git on the mainframe. So we have your development, your source code management, might be Git, might be Bitbucket, it doesn't matter. You can just check in your COBOL code there, or your artifacts that you produced by using ZOS Connect or any other tool, and just put them in the DevOps pipeline as well. So the whole DevOps pipeline, I see always customers say, oh yeah, but on mainframe we do it differently. And there might be a very good reason to do so, but technically there's no reason to do it differently than on any other platform. So just bear that in mind, that it's nothing, it doesn't necessarily need to smell different. On the platform, on the traditional enterprise, we see also that, of course, for many, many years we can run Java workload, about 20 years ago. So we now call it the Jakarta EE, because we Oracle open sourced the Java to Eclipse, so they renamed it as Jakarta EE. But yes, you can run Python, yes, you can run R, yes, you can run the Spring frameworks, Node.js, a very significant part of that runs the Zoe interface, and yes, also Apple's Swift application. So you can see that from there we do integrate with that cloud platform pretty much. Already mentioned on the right hand side, so the consumer doesn't care too much where it runs, but on the operations part we have the Zoe interface that makes life so much more cloud native, so to speak. Okay, I've mentioned the word Swift a couple of times now, so let's zoom in on what we mean by Swift. So Swift is a programming language from Apple. They announced it at their WW Developer Conference in 2014. And Martjin mainly and his brother Robin were jumping up and down. Well, we have a new programming language on Apple, and you could actually, if you even have an iPad, you could start coding in something called the playground. You don't necessarily have all the compiler stuff, it's just playing around. And I'm not a developer. I mean, I would insult anybody who is a developer to say that I'm a developer, but of course I play around with it. And the previous version of Swift, called Objective-C, I never get my head around. I found it extremely cryptic, and it was so old. Basically, it was from Steve Jobs out of the company thing called Next. His project Next, he still uses some code of there. And Swift was a breath of fresh air. It was easy to understand. I'm not a developer, but it's so much easier to understand, not so much cryptic. A year later, they announced that they will open source Swift. So that was 2015. And I was thinking, why? Because you still need, I thought, a Mac, an Xcode, and an Apple device to run your code on. But that was not the case. The Apple decided to leave out a couple of things that they need for those devices. They called it the UI, the user interface kit, for example. And what's left was a very stable, modern application environment that could run easily code on any platform. Also, the server side of applications. And then it became very, very interested. So at Interconnect, our worldwide conference, now rebranded as Think, we announced that Swift and IBM would come together so that IBM would support Swift on every platform, whether it's the cloud, the Power Platform, and also the mainframe. And one of the things IBM put in the open source community was to develop an open source web framework, completely written in Swift, and that's what we call the Kitura framework. So the Kitura framework, you just install it as a module into Swift, and it will handle all your web server functionalities like security, and it renders HTML pages for you, etc., etc. And about a year and a half ago, IBM then announced the IBM Toolkit for Swift for ZOS. So there you get the whole stuff that you can install on a ZOS environment, that is. To do it. And we basically use all of that in this presentation. So yeah, the Swift, although relatively new, it has industry backing, it has an enormous developer acceptance. Depending on which website you're looking, it's about the 8th or the 10th or the 7th most popular languages. It's at least the fastest growing one. There are many tools and packages out there, and yes, there are conferences and meetups, etc. to do it. So far, one last slide before we went into the Martijn's presentation. You might argue, why do we need yet another language on Z? We have the traditionals, we have Java, we have C, we have Node.js, why another one? Well, there might be a couple of things. I think also in the whole digital transformation and the cloud chapter 2.0, it makes sense to have to start in the middle part. To have a new language that is born on the cloud, that understands JSON by heart, etc. It's extremely performant compared to Java. It's a compiled language, so you can actually have code, compile it, link edit it with already existing code. So, for example, with PL1, you have PL1 running, wonderful module, been there, tested, hammered on, worked perfectly. Why not take that module and compile it with a new front end rendered by the Kitura framework? I mean, it's so easy to make that kind of things. And from a performance CPU and a memory standpoint, its performance pretty awful. So that's why. And of course, you have the cloud native experience. And as always goes, I mean, one of the use cases that you might have to, if you run an application on Swift on ZOS, it should be close to the data. It doesn't make sense to develop something on Z that doesn't have any relation with the data or applications that's already out there. So with that said, I'm done.
How does it compare to Node.js? You mentioned Node.js. How would I decide to use Node.js for Swift?
So the question is, what is the difference between Node.js and Swift, and why you use one above the other? Well, Node.js is, what I see, is more a front-end application, rendering front-end stuff. Because of the construct of Node.js, it's not a compiled language, it's just an interpreted or just-in-time compiled language. I don't see to run it thousands of transactions per second, so to speak. Whereas Swift, because it's a compiled language, it's more compact for that, and you can have the benefits of the underlying infrastructure. I see Swift as being more to run business logic. It won't replace Kix or IMS for that matter, but that will be a large. You can see the Zoe framework is built in Node.js because it has that front-end interaction much more than running real business applications. And I see Swift more capable of doing that. Yeah. Okay, so I'm off. Enjoy the next speaker, which happens to be my son. Here you go.
Hello everyone, my name is Martjin and I'm a student currently. I'm doing application and media development at school. I also do an internship right now at a company called We Build Apps. I've been doing iOS and Swift for a couple of years now. And Frank asked me, do you want to go on a project with a few other people to make a full stack Swift application running on the mainframe? And I thought, I don't know, I have never worked with a mainframe before, I don't know anything about that, I only worked on Xcode and on the Mac. So at first I was kind of skeptical, but actually with this presentation I want to tell you that for me, coming from Xcode and developing on my own devices, it was really easy to transition to developing on, for example, a mainframe. So what we did is we took this Kix application, and this is a sample application that IBM provides you if you purchase Kix. So this Kix application usually holds office supplies for you, but we changed them to contain longboards because we wanted to make a longboard shop where you can see longboards, few information about them, and finally order a longboard. So you can see that here we have a couple of weird names, but that's okay, I think. This is also this application also provides 3 functions. Here we see the first one. This is loading all the longboards. That's the first function of this Kix application. The second one is viewing more detail about a longboard. And the third action is ordering a longboard. And we took those actions and REST API enabled them with ZOS, ZOS Connect, as Frank mentioned. So that Kix, so that Kitura and Swift can talk and call these APIs. So this is a little bit of a walkthrough of the infrastructure components. You can see here on the right we have the mainframe that is on premise. So this is running ZOS, and as I told you, here you have your Kix application. You have your ZOS Connect to REST API enable those. And then we have 2 Swift applications. One is running on Linux 1, as you can see to the left here. And one running on the IBM Z. Now you might think, why is that? Well, we thought this was typical in like a multi-tier environment. You have usually some kind of front-end web server. So in our case, this was the Linux 1. And we have a mainframe that holds the application so that the application is more is closer to your backend. Also, Swift is able to reuse existing PL1 routines. And on the Linux 1, we have a couch database to hold extra images and information about the longboards. And on the Linux 1 is also installed Red Hat OpenShift. So what will happen is a user will request a web page, then a request will get sent to the Linux 1 server. That will route a request to the Swift application running on IBM Z. And that Swift application will call the REST API to Kix, and Kix will return the longboards items as JSON, which up till now is only text, only character based. It will then send this JSON to the front-end server, being the Linux 1, and it will apply images from the Couch database, and then Swift Kitura will render the web page and send it back to the user. And also, if there's a lot of users on the website, ICU has developed something that scales up this application accordingly. So that's a very good development on this project. And in case of a mobile phone, we have the JSON comes back instead of HTML. So now I want to focus a little bit on making a transition from iOS development to working on a mainframe and making an application in Swift there. So you don't have to understand any of this code, but basically what this does is it creates a web request to retrieve some data and then update the user interface accordingly. And on the bottom here we have a piece of code to also make a data request to get JSON back. And as you can see, they use the same functions and methods, which for me was really easy to transition from what I already know and love of Swift on my Mac and transition to that on the mainframe, because it's the same code almost. Of course, there's differences because one the iOS app has to update the UI, whereas the Swift on the server side does not need to. So, but then what was actually different? Well, you have, if you make an iPhone app, you have Xcode. I mentioned it a couple of times. It's an IDE for making iOS apps. It has some great features like code completion, early error detecting. It has a debugger, which is an LLDB debugger. And it has a really handy build and run button. So if you want to test it out, you just click the button, it deploys on your device, and you can test right away. So on the server side, this was a little bit different. But when you start with a new project, on Xcode you have a nice UI and a graphical user interface to start a new project. On the server side, you have to initialize a project. And then from that, the package manager will be able to manage dependencies where you can add, for example, Kitura. And you can also generate an Xcode project. And an Xcode project is a project that Xcode can open. So I could actually edit my code right in Xcode as if I were writing for an iPhone, but I was writing for a server-side Swift application. So as Frank mentioned, on ZOS, we don't have Git clones. We have an IBM toolkit for Swift, which you can download. If you're running it on Linux, you just get the Git clones. So how do we get this great build and run type of thing that we have in Xcode? Well, it's a simple command line interface for Swift build. You just type Swift build, you have Swift run, and you can also access the package manager if you type in Swift package. So as I mentioned, I edited some code in Xcode, but you can do it in any editor you like. You can use IBM Developer for Z, you can use Atom, you can use Visual Studio Code, you can really use anything you want. And on Linux we have a LLDB debugger, so that's the same debugger you would find on Xcode. Sadly, it isn't on ZOS. So now for the demo. Here's my iPhone. I've got the app, the longboard app, and as you can see, this is these are the longboards, and this is the first call we made to our Kicks application. So this is retrieving all the longboards, and you can see the prices and everything. If I click on one, so say I click on the Basalt Tesseract, I'll get an image, a more detailed image. So this is from our Couch database on the front-end web server. And we can see additional information like in stock and a small description and some text specs. So I can add it to my shopping cart, so I'll do that. And I'll go to my shopping cart, and now we can invoke our third action, which is making an order. So I'll press the order button, I'll authenticate, and as you can see, order successfully placed. So our Kix application returned that the order has been placed and everything went successful. So that's my part of the presentation. Sorry.
Okay, so for those who are in Kix, namely Nigel, do you ever thought that you have an order that you have to approve that in a Kix environment? Probably not, but okay, so thanks very much, Martijn. So the third part was developed by a business partner of IBM called ICU, that we were using their Linux 1 to run the first tier on. And Chris is actually the guy who worked on first ICP, but later on Red Hat OpenShift to make that happen. And Chris is 24 years old, so the two together were very young to do that. Basically, what Chris did was basically focusing now on that part. That's their environment. And initially, when we started with this project, we were, especially the guys, were talking by means of WhatsApp. So, okay, Martijn talking to Chris, we see a growing interest, so we need to speed up things. So then we have Chris and going to the console and speed up some and start up some other instances of it. But that's basically not what you want. It's okay, that's cool for development, but in real life you would like to automate that as much as possible. So what ICU developed, is not so much me or Martijn, but ICU actually developed that we have an automatic scaling down and also an automatic deployment. And especially for that deployment part, they went just to have a couple of those tools like Docker containers, Bitbucket, and later OpenShift or ICP in the beginning. Just basically go fast to a production environment, completely do it yourself. Sorry, don't interact too much, automate everything, and get only a notification if something went wrong. So what they developed is on the left kind of circle is the wall development, being Martijn and his brother. They committed into the Bitbucket the new Swift code. And they have the Bitbucket then, and whenever something came in there, it's being built, and also built in a Docker environment for that. In case of an error, Martijn get a message, and the whole process started again. But of course, in case when everything went okay, they containerized the application and pushed the image to the catalog. And then automatically OpenShift puts it on, or OKD at this moment, the commercial build of OpenShift, on their Linux 1, and off they go. So it's a very automated process, no manual interaction anymore, and even also in the scaling up, they decided to make that automated. So in this case, the requirements again was to keep production availability, not so much to do anything manual. And Red Hat OpenShift has that capabilities, and just say, well, the guy that's Chris's words, I'm just being lazy, I don't want to do any manual work. So if the demand came up, they were just spinning up another couple of containers to disperse the work, and then scale down automatically if demand slowed down. Okay, so that was basically the whole presentation. If you want to have any feedback or any questions, we still have about, you went fast, 15 minutes. You should have done slower, but okay, we did. Okay, so far that's the presentation. Any questions, remarks?
Question for me, I guess probably maybe for you.
And talking to...
touched the mainframe before. Did
Yeah.
you have to have any interaction at all with NSX Connect or with Kix? Did you need to find out about that?
Yeah, like obviously my father helped me a little bit with editing the Kix FSM file, and of course like ZOS Connect, those kind of things. But like the big thing is like once you're up and running, like of course you need some people that have some knowledge of mainframes. But if you're up and running, I didn't really need any more things from them. I could just develop on my own, really. Yeah. Anyone else? So Bitbucket is a source code management system. You have many companies that do this, but basically you can upload your code, and if someone else is working on the same project, they can request that code and make changes to it and upload it again, and then I can get their latest release, so we don't have to share files, and it basically just manages that the code you have is always like the latest, and it's for sharing. It's really great. So
It's like a kit.
yeah, good question.
The images that you use for the boards themselves,
Yeah.
storing them on a database with Couch.
Yeah.
Is that that's the best place to store them, or could you have moved them onto another part of the whole process?
Well, we could have got them onto a DB2 database, but we decided that since it was already at the front end, we might as well just keep the images there rather than moving them all the way across like the back end and then on the front end server. So we thought this was like the best solution, but you could have stored them anywhere in the stack. Yeah.
And also in that respect, Piet, this was a NoSQL database. Couch database is a NoSQL database. Typically easy to store images. And also in this scenario, I mean, the young people don't know the DB2 by heart. They use NoSQL databases. Typically you run it on a Linux environment close to where you are. So like Martijn said, you don't have to do that. And of course Swift itself knows very easy to connect to a NoSQL database and get the JSON and transform it to the data format that an iPhone or a Xcode is using, called the dictionaries. So that was, yeah.
Martijn,
Good.
if you would do this again, would you do anything differently?
I don't think so actually. It was pretty straightforward. No, I don't think so actually.
A different day, perhaps.
Yeah, good question. Okay. Yeah. Okay. Well, thank you all for your time. Yeah.
Thanks.
Thanks.